For the mixed factoring section, you want to first find a greatest common factor if possible, and then you want to factor using other methods for what's left over. So first find a greatest common factor if possible. Sometimes there's not one, but if possible, pull that out front. And then you want to factor what's left over using other methods. So always look for a greatest common factor first. Then using other methods, if it has two terms left, then you can only use difference of two squares or sum and difference of cubes. So those are the only two options you would have left at that point. And if you have three terms left, you can only factor those using the trinomial methods, whether a equals 1 or a is greater than 1. And if you have four terms, then you can only use grouping. So remember, those are your only options based off of how many terms you have left. All right, so let's try a couple of examples to get you started. So for 59, I see I have 81 minus 3a cubed. So first I want to divide both by a greatest common factor of 3. All right, so that would leave me with 3 out front, and I have 27 minus, and I don't have 3 anymore, minus a cubed. So I've divided out the greatest common factor, I've written it out front, but I notice what's left over is a difference of cubes, because I have two terms. So remember, two terms, I've only got difference of squares, which that's not what this is, and I can use difference of cubes or sum of cubes, which I notice that's what I've got left over. So I'm going to take the 3, keep that out front. I'm going to write a binomial and a trinomial factor. I see I have a minus sign, so my signs are going to be minus, plus, plus, or same, opposite, always positive. Remember, SOAP goes with that type of factoring. And I'm going to take the cube root of 27, which gives me 3, and the cube root of a cubed, which gives me a. And then I can take my first terms and get my trinomial. So these two in a binomial are going to give me my trinomial. I have to square the first term to get the first term, so that would give me 9. I have to square the last to get the last, so that would give me a squared. And then I got to multiply those two together, ignoring the sign, and put that in the middle. So that'll be 3a. So I'm going to repeat myself. I got to square the first term to get the first term in the trinomial, which would give me 9. I got to square the second term in the binomial to get the last term in the trinomial, so that'd be a squared. And then I have to multiply these two together, but ignore the signs because they always follow a specific pattern. Okay, so that's it. I've now factored it completely. Let's look at another example. So let's do 60. I notice I have a negative 2, so I definitely would like to take out the negative, and I hope I could take out the 2 as well. And it does look like that would be possible because 10 and 72 all divide by 2. But let's take out that negative because it's always good to take a negative out front if you can to make that first term positive. They do not all have q, so I can't take any of those out. But then I end up with q to the 4th power plus 5q squared minus 36. So then I need to leave negative 2 out front because that was my greatest common factor. And what I have left is a trinomial, so I need to break that up into 2 binomials. And I need to think of what would help me to multiply to get negative 36 and also add to give me 5. And so what would help me is negative 9 times 4, because that multiplies to give me negative 36, and negative 9 plus 4 would give me, actually that would give me negative 5. Whoops, so let's change the sign of those to make sure this works out. So 9 times negative 4 gives me negative 36. And 9 plus negative 4 would give me 5, so that looks better. So then I need to put in place, I have q squared. Since my a value was just 1, I could do it with the more simple methods for this one. So q squared plus 9, q squared minus 4. And then I noticed that that q squared minus 4 is a difference of squares. So I've got to actually do one more step and factor that one a little further. I can't factor q squared plus 9 because that's a sum of squares. But I can take this binomial and do a difference of squares. So I need to say q would go in both, and then the square root of 4 is 2, and put plus or minus one of each. Now I factored it completely using all the methods that were appropriate. Okay, so hopefully that helps get you started with the mixed factoring section.